Today we're doing lesson 3.6, using perpendicular and parallel lines. This is our last lesson in chapter 3, which means we've got quizzes and tests coming up. Our objective will be to use the properties of parallel and perpendicular lines. Our first challenge is to draw a line and a point not on the line, and draw as many lines as we can that pass through this original point that is parallel to this original line. So we have a line that's going through the point parallel to that first line. I can do a little, nope, that's too low. That's a little better. Okay, so we're going, sorry, I just can't seem to get it to stick where I want it to. Close enough. Through the point, parallel to this line. Now, if I draw another line up here, okay, like, yes, I could make a line that goes more through the top of the point, but really, like, this should be centered on the point. It shouldn't matter how big or small my point is. If I put any other line in here that goes through that point, are any of the other ones going to be parallel to that line? No. So, we can only draw one line that fits those conditions perfectly. Okay, only one. So that brings us to our first postulate, the parallel postulate. This goes in your notes. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. You will. The parallel postulate was Euclid's fifth postulate. It was also the postulate he used the least in his proofs of other theorems. Many mathematicians through the ages felt that this should never have been a postulate at all. Remember, postulates are accepted without proof. Many mathematicians have argued that the parallel postulate was not worthy of being a postulate, that it needed a proof. How would we prove that there is only one line that goes through that point parallel to the other line? Okay, drawing all of them seems like the only real way to prove it. However, there are infinitely many lines that would go through that point, so we could keep on drawing more and more lines forever. So I believe that's why Euclid thought it should be a postulate. We just needed to accept it. But other mathematicians disagreed. Our next postulate is the perpendicular postulate. It's very similar, just instead of having a parallel line, we've got a perpendicular line. So if there is a line and a point not on the line, then there exists one line through the point perpendicular to the given line. Again, we could not draw any other lines through this blue point that would be perpendicular to the black line below. There's only one line that will fit both of those conditions. All right. So here's a question just to consider. The answer is also on the board. But if John is Peter's brother and Joe is Peter's brother, then how are John and Joe related? Now, unless there are more weird family dynamics that they didn't tell us about, we would probably assume that John and Joe are also brothers. Okay, this is going to lead in nicely to the next theorem. So our theorem says, which if you want to write this, you can, but we've got a simplified version on the next slide, so I would maybe hold off on writing it. You could draw the diagram. Theorem 311 states, if line Q is parallel to line R, which they're both marked with one arrow, so we know they're parallel, and line R is parallel to line S, so they're both marked with double arrows, then how do we think lines Q and S are related? Any guesses? No guesses. We just want to be surprised? Yeah. Okay. Lines Q and S are also going to be parallel. So this is the shortened version of stating that theorem. right up here. This is the theorem that we need for theorem 311. If Q is parallel to R and R is parallel to S, then Q is parallel to S. This is the same logic as syllogism, or it should look similar to the transitive property. Right, the transitive property was when we had things equal to each other, but here we see kind of the same idea. Make sure you get this if-then statement in there for the theorem and the diagram that goes along with it. All right, our next one, again, I'm fine if you just have the shortened version of it with the symbols, but you have to have the diagram to go along with it. So theorem 312, the long way of stating it is that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. For this diagram, we would say that if M is perpendicular to P and N is perpendicular to P, then we know lines M and N are parallel to each other. All right, letter A, I'm hoping is pretty easy because that is exactly what we just saw in one of our theorems. Okay, so if A is parallel to B, B is parallel to C, we have to explain why A and C are parallel. So if they're telling us to explain why, that means they are parallel. We just have to explain how we know that to be true. All right, so I already heard somebody whisper it. Does anybody want to say it a little louder? How do we know that? Theorem 311. So again, Theorem 311 doesn't mean a whole lot to us in general. So we could say that because that's what we just talked about. Or you could say that A and C are both parallel to B. So they're parallel to the same line. They must be parallel to each other. So the reason why we know that A and C are parallel on example 1A is because they are both, A and C are both parallel to line B. That came straight out of Theorem 311 that we just talked about on the front. Letter B, example B, we have to do a little bit more explaining because right now we don't know anything about line A being parallel to anything else. Okay, if we just look at line A, which line could we prove it to be parallel to right off the bat? Line B. Okay, they told us that angles 1 and 2 are congruent. If 1 and 2 are congruent, then lines A and B have to be parallel to each other. But why? So we're on the right track. We got to state it one of two different ways. Corresponding angles. What about them? This goes back to what we did in the warm-up. Corresponding angles are congruent. So we know for sure that lines A and B are parallel because the corresponding angles converse or corresponding angles are congruent. Okay, so if I know A and B are parallel, I can go ahead and mark that. I'll use 2 triangles because we've already used 1 for B and C. But now it's back to the same situation we had in part A. A is parallel to B, B is parallel to C, so therefore A has to be parallel to C because both are parallel to B, or Theorem 311 again. So that one, it took 2 steps to fully explain how we knew that. We had to first explain why A is parallel to B, and then we could talk about why we know A is parallel to C. All right. We are going to find the value of x that forces lines WX and YZ to be parallel to each other. Now, in order for these lines to be parallel, we need to decide how we need these 2 angles that are marked to be related. What is their angle relationship from our 4 options from last week? These 2 angles. They are same side interior, and if lines are going to be parallel, same side interior angles are going to be supplementary or add up to 180. So I have 2 options here. One option, like the standard option, is to set up just the full equation. I know that 2x minus 6 plus, how many degrees is this? 90, needs to equal 180. Now, if you are a wonderful geometer and you can just look at this and say, well, if that's 90, I know that has to be 90, and you start from there, you set this 12x minus 6 equal to 90, I would accept that, but you need to show me your starting point, your beginning equation. I'm going to go ahead and work with the one I have written. So 12x, if we combine negative 6 plus 90, what do we get? A positive 84. That is still set equal to 180. Who can help me continue to solve this? Angel? Subtract 84 from both sides. That leaves us with 12x equals 96. Then what? Divide 96 by 12. We get x equals 8. Very good. Ready to move on. Okay? All right, number 5 is pretty similar to the one we just did. What's the relationship between these 2 angles? Still same side interior. So if these lines M and N are going to be parallel, we still want those to add up to 180. Add them together, set it equal to 180. First step. Subtract the 90. We get 15x equals 90. And then we would have to divide by 15. What do we get for x? X equals 6. Very good. All right, on number 6. This one's a little bit different. These are not same side interior. What are they? Alternate interior. Alternate interior angles with parallel lines need to be congruent. I was hoping more of us would sound more confident in that answer. If they are congruent, I'm going to take 3x plus 15, and I'm going to take 90, and what symbol am I going to put in between them? An equal sign. Very good. Okay, so these 2 angles have to be equal to each other. The box means 90-degree angle. There we go. Can somebody new raise their hand and help me solve? You're going to make me pick on somebody for the last one. Quentin, what am I going to do?
Subtract 15 from 90.
Wonderful. Divide 75 by 3. What do we get? Anybody? 25. X equals 25.